We are back to the enemy movement in Pac-Man, and we still have quite a bit of work left to do. Now, I would like to offer some explanation on this desired direction variable. Some of you might be asking, why on earth do we have two direction variables? Why can we not just settle with one? Now, I would like to offer some explanation on that. So first of all, the direction variable is the one who is ultimately going to influence the movement of the ghost. So the changing of coordinate will only happen depending on the value of this direction variable. Now, we invented this second desired direction variable to keep track of the direction that the ghost will think it should choose so that it could reach Pac-Man in the shortest amount of time possible. If, for example, Pac-Man is on the other side of the wall, then this desired direction would lead me to go to the right, which would lead me to collide with the wall. So this desired direction may not always be the best, and we should always keep direction influence the movement. So I'm going to start with a small condition first. I'm going to go to control, and I'm going to bring in an if block. And I'm going to go to operators and bring in an equals. So if the direction, so the absolute direction is equal to stay, so if direction is equal to stay, then I'm going to set direction to a random value. So I need to be able to generate a random number between 1 to 4, and depending on that number, just pick direction to be up, down, left, or right. So I'm going to make a simple variable for this sprite only, and I'm going to name this random number. So I'm going to set this random number variable to be, I'm going to go to operators, and I'm going to bring this pick random 1 to 4. Now, depending on what value this variable ends up being, I'm going to pick up, down, left, or right. So I'm going to go to control, and I'm going to bring in 4 if blocks. So 2, and then another 2. And I'm going to set this here. So if this random number is 1, then I'm going to pick up. So I'm going to go to operators, snap this inside, random number. So if this random number is 1, then set the direction to up. Now I made the mistake of copying these if blocks too early. I would like to copy them now. So I'm going to duplicate them now. So we have the random number equals 1 to set direction to up. If the random number is 2, I'm going to decide direction should be down. If random number is 3, I'm going to decide left. And if random number is 4, I'm going to decide right. Now I could snap this entire script into this already pretty big script, but that would make the script exceedingly complicated, so I'm going to make a custom block instead, and I'm going to name this pick random direction. I'm going to hit OK, and I'm going to define it as the script that I've just written. And here I'm going to use pick random direction right after point in direction 90. So before we compute the desired direction, we are going to pick a random absolute direction. So the reason we created this pick random direction block is that if desired direction, so the quote-unquote best direction for this sprite, leads me into colliding with a wall, I still need to move and go somewhere, not get stuck here in the wall. So that's why I created this block. Now, speaking of collisions, we need to add a similar piece of logic for the desired direction. So we should make the desired direction equal to stay if it's leading me into collide first if check, and I'm going to duplicate it, and I'm going to snap all these if checks after the first 4. Obviously, I'm going to delete the second switch costume, and in the last 4 if checks, I'm going to remove direction, and I'm going to put in desired direction. So put it in the 4 spaces that we created. And in the results here, I'm setting the desired direction to stay in either case. So desired direction and desired direction. Now, the reason why we're doing 2 sets of checks is that, as I mentioned, direction and desired direction may have 2 very different values, so we need to check both. Now, after all of these checks, direction and desired direction will have 2 different values. Now, our goal here is to set the final direction value to something that depends on the desired direction as well. Now, here's the thing. Let me change the costumes here so you can see better. Let's say that Inky is right over here in this corner and Pac-Man is right over here. The desired direction would obviously be left, so this is where Inky would think it would get Pac-Man in the shortest amount of time. Now, of course, Inky would be stuck here in the corner of the maze because it's not allowed to move. Now, at the beginning, Inky's direction is set to random, so it might be the case that the direction would allow Inky, for example, to go down and bypass this wall. Now, if at the end of this script, direction and desired direction are different, we'd like to pick one or the other depending on some kind of coin toss. So I'm going to go to control and I'm going to bring in an if block. So I'm going to bring in an and in the first space, I'm going to impose that the desired direction is not equal to stay. So if the desired direction pushes Inky towards some direction, so if not desired direction equals to stay, so if not desired direction equals stay, and some kind of coin toss here on the right hand side. Now, how do we implement a coin toss with numbers? Well, we would generate a number between 1 and 2. So the heads of this imaginary coin would be 1 and the tails of this imaginary coin would be 2. And we would force that the coin toss should have, for example, heads, so that the random number generator would pick 1. So if the random number generator picks 1, then we should pick desired direction to be the final direction. If the coin toss decides that the number is 2, so that's tails, we will decide the final direction to be the original direction that was picked at random at the beginning. All right, so here's how I'm going to do it. I'm going to bring in an equal sign, and I'm going to force this random number generator to be 1. So this random number generator will pick a number between 1 and 2, and I want this random number generator to pick 1. So if the desired direction is not stay, so the desired direction is somewhere, up, down, left, or right, and the random number generator picks 1, then I'm going to set the final direction, so set direction to be desired direction. So I'm going to snap this if right below the costume switch. And speaking of the costume switch, because we're going to have multiple ghosts on the screen, each ghost should know its original costume. So I'm going to create a small variable for this sprite only, and I'm going to name this costume ID. And at the beginning, I'm going to go to looks, and I'm going to set the costume ID to be, from looks, the costume number. So the original costume number that this sprite was generated with, I'm going to set its costume ID to be its costume number, so that then, after I end up the collision checks, I'm going to switch the costume back to that costume number, because otherwise I'm not going to remember which costume I had. So I'm going to switch costume to costume ID. So think about it. If I didn't have this costume ID variable and we had like 4 ghosts on the screen and our original costume was red, how would we know to switch costume back to the red costume and for the other ghost to switch the costume back to the blue costume, and so on and so forth? So every single sprite, every single ghost would need to remember which costume ID it originally had, which is what we are doing here at the beginning of this script. So that being said, let's make the ghost actually have some targets. I'm going to add another script starting with when flag clicked, and I'm going to set some targets for the ghost. So I'm going to go to variables and I'm going to set target X and set target Y. Now, what values should these variables have? Well, when the ghost starts at the beginning here in the cage, its target should be the exit of the cage. And the values for the target X and target Y are going to be target X equals 0 and target Y is 48, which is the position where the cherries here are on the screen. Now I'm going to wait until these coordinates are met. So I'm going to go to control and I'm going to wait until X position is 0 and target and X position is 48. So I'm going to go to operators and bring in and 2 equal signs. So 1, 2. And I'm going to say X position should be equal to 0 and Y position should be equal to 48. Now at this point, the ghost has exited the cage. After that, I'm going to set new targets to the ghost, which will be the original position of Pac-Man. So I'm going to go to variables back and I'm going to set target X to 0 and target Y to -80, which is the position where Pac-Man originally starts. So at this point, I'm glad to say that we should be quite done with the movement of the ghost. The ghost will start in its original position, so -16, -16, and it has some targets, 0 and 48, and then another target, 0 and -80. And we have our movement and direction decision script. So I'm ready to hit the flag now, fingers crossed, because we wrote a lot of code. So notice that the ghost starts here in the cage, and it's exited the cage, and it moves towards Pac-Man. This is amazing. So right now, I want you to just take a step back and congratulate yourself because we've done the hardest part of the entire game and maybe the entire course. I don't really remember us writing such big scripts. And the result of these scripts is intelligent enemies that can move on their own. So notice that no user input was added into either one of these scripts. The ghost moves entirely on its own programming. So join me in the next video as we will create the other clones that will go after Pac-Man on their own.